Hello friends, my name is Diganjit Rawal, ME Mechanical Design Engineering, lecturer in Automobile Engineering, Government Polytechnic, Nasik. This presentation is on numericals on vehicle performance. In the previous presentation of vehicle performance, we have seen the different parameters of vehicle performance. We have seen the resistances, different resistances, air resistance, rolling resistance, gradient resistance, as well as we have seen the difference between engine speed and vehicle speed. What are the power required of the vehicle? What is the formula for that? So here the content is the two numericals. We have to calculate the different parameters of vehicle performance. So this is numerical number 1 for the vehicle performance. In this numerical, the engine of a Jeep is known to be able to provide 40.5 brake power BK watt for propulsion purpose. In a certain application, the Jeep weighing 12,459 Newton is required to pull a trailer of gross weight 10,673 Newton at a speed of 57.75 km per hour in top gear on level. The resistance to motion is given by the equation R is equal to AW plus BV square, where A is equal to 0.016 and B is equal to 0.055. Here the W is in Newton and V in kilometer per hour. Find out if the Jeep is adequate for the job if the transmission efficiency is 90%. What is the pull in the coupling at this speed? So speed remains same 57.75. If second condition, if the available power is just utilized in top gear by suitably loading the trailer, what is the pull in the coupling at 57.75 km per hour? So here the engine of Jeep provide power, the value is 40.5 watt, and Jeep weighing, the weight of the Jeep is 12,459 Newton and trailer of gross weight is 10,673 Newton. The speed of the vehicle, capital V, is 57.75 km per hour in the top gear on level ground. Next, here we have consider resistance to motion, capital R is equal to AW plus BV square, where small a is equal to 0.016 and small b is equal to 0.055. Whereas in the equation R, W is in Newton, V in kilometer per hour. So here we have to find out Jeep is adequate for the job or not. Jeep is doing his work or not. So we have to calculate R and F. Again, we have to consider transmission efficiency eta T is equal to 0.9, and we have to also calculate the pull in the coupling at this speed. So speed is 57.75, and again we have to calculate the power that is in top gear for pull in the coupling at 57.75 kilometer per hour. So these are the given in this numerical. So next one, we have to check what is given, what is to find out in this numerical. So here I have explained regarding given the total weight is equal to jeep weighing plus trailer gross weight. So we know the value of jeep weighing, we know the value of trailer gross weight. So W is equal to 12,459 plus 10,673 Newton. We also know the value of small a and small b. The small a is equal to 0.016, b is equal to 0.055. V, the speed of the vehicle, 57.75 kilometer per hour. BP, brake power, is equal to 40.5 watt. Transmission efficiency is 0.9. And here we have to find out resistance to motion and tractive effort and total pull. So this is our given, and we have to find out three parameters in the vehicle performance numerical. So next one. So solution, first we have to calculate total weight W. So 12,459 plus 10,673 is equal to 23,132 Newton. So addition of these two, the W becomes 23,132 Newton. Next, we have to calculate resistance to motion. We have the equation for R is equal to AW plus BV square is equal to 0.016 W plus 0.055 V square. In this A and B, we know the value of A and B, as well as we know the value of W and V. So putting these values is equal to 0.016 into 23,132 plus 0.055 into 57.75 whole square. Okay, so V square. So that values comes as 370.11 plus 183.20, and that R becomes 553.32 Newton. So this is the resistance to motion, R value in Newton. Next, we have to calculate tractive effort. So F is equal to BP into 1000 into transmission efficiency divided by V, where V is in meter per second. So we know the value of BP, we know the value of transmission efficiency, we know the value of capital V. So put all this value in the equation. F is equal to BP into 1000 into transmission efficiency divided by capital V. So F is equal to 40.5 into 1000 into 0.9 into 60 into 60 divided by 57.75 into 1000. So why this 60 into 60 divided by 1000? Because we have to convert that V from kilometer per hour into meter per second. So that's why we have to multiply by 60 into 60 divided by 1000. So the F becomes 2272.2 Newton. Since F is greater than R, here tractive effort is greater than resistance to motion, so that the GP is adequate for the job. When F is less than capital R, when tractive effort is less than resistance to motion, then GP is not adequate for the job. But we got the value of F is greater than R, so our GP is adequate for the job. Next, the pull in the coupling at this speed is equal to A into gross weight of trailer. So that is equal to 170.8 Newton. So we know the value of A 0.016 into gross weight of the trailer is 10,673. So multiplication of this, we will get the value as 170.8 Newton. So this is the pull in the coupling at this speed. Next, if more weight is added on the trailer, if we increase the weight of trailer, and so that the tractive effort available is just sufficient to work against the resistance to motion at the same speed, then the extra pull on the coupling is equal to tractive effort minus resistance to motion. So when we calculate extra pull on the coupling, So we have to check that the value of tractive effort and value of resistance to motion. So we have find out the value of tractive effort as well as we have find out the resistance to motion in previous slide. So extra pull on the coupling is equal to 2272.2 minus 553.3, that is equal to 1718.9 Newton. Hence, the total pull on the coupling at same speed with extra loading, that is equal to extra pull on the coupling plus pull in the coupling. So, in this pull in the coupling, already we have find out extra pull on the coupling. We calculated this as a tractive effort minus resistance to motion, so that the total pull on the coupling is 1718.9 plus 170.8 is equal to 1889.7 Newton. So this is our value for total pull on the coupling at same speed with extra loading. So next, this is the summary for numerical 1. We have first read the numerical completely with full concentration. Then step 2, we have to find out what are the givens in the numerical. Then we have to check what is to find out, what is to calculate in this numerical. So our given is total weight is equal to jeep weighing plus trailer gross weight. So we know the value of W, total weight. Then small a, small b are the values given in the numerical. V, speed of the vehicle is given in kilometer per hour. Brake power BP is equal to 40.5 watt is given in the numerical. Eta T, transmission efficiency 0.9 is given in the numerical. So resistance to motion, tractive effort and total pull we have to find out for this numerical. Next, in the summary, we first find out the value of W, then we find out the value of resistance to motion, that is the equation we know R is equal to AW plus BV square. Then we check that the value of R, that is 553.32 Newton. Then we calculate the tractive effort F. We know the formula for F, BP into 1000 into transmission efficiency divided by V, whereas V is equal to meter per second in meter per second. Next, for resistance to motion, we consider V in kilometer per hour. But in tractive effort, we have to consider V in meter per second. This is the main difference. So we get the value of F as a 2272.2 Newton. So we get F is greater than R, then we know that GP is adequate for the job. Next, we calculate the pull in the coupling at this speed. At this speed means 57.75 kilometer per hour. So we calculate is equal to R is equal to A is equal to A into gross weight of the trailer. So that becomes 170.8 Newton. Then the extra pull on the coupling, then we extra pull on the coupling is equal to tractive effort minus resistance to motion. So we find out this extra pull on the coupling, and that value becomes 1718.9 Newton. Hence the total pull on the coupling at same speed with extra loading, then this value becomes 1889 Newton. So this is all about the numerical number 1. So we find out value of R, value of F, then pull of the vehicle and total pull of the vehicle for the speed 57.75 kilometer per hour. I think you have you have all the learn this concept very clearly and understood the numerical very well. Next numerical, second numerical, the coefficient of rolling resistance for a truck weighing 62,293.5 Newton is 0.018 and the coefficient of air resistance is 0.0276. In the formula, R is equal to Kw plus Ka capital A V square, where in Newton. So in this formula, R is in Newton, where A is meter square of frontal area, V is in the speed, V is the speed in kilometer per hour. The transmission efficiency in the top gear of 6.2 is to 1 is 90%, and that in the second gear of 15 is to 1 is 80%. The frontal area is 5.574 meter square. If the truck has to have a maximum speed of 88 kilometer per hour in the top gear, calculate the first one, the engine brake power required. Second, the engine speed if the driving wheels have an effective diameter of 0.8125 meter. Third one, the maximum grade the truck can negotiate at the above engine speed in second gear. And fourth one, the maximum drawbar pull available on level at the above engine speed in second gear. So here we have to find out four values for vehicle performance. The givens are coefficient of rolling resistance, that is 0.018, then truck weight 62,293.5 Newton, coefficient of air resistance Ka is equal to 0.0276, and capital A is given 5.574 meter square. Then the for top gear, the gear ratio is 6.2 and transmission efficiency is 0.9. For in second gear, the gear ratio is 15 is to 1 and transmission efficiency is 0.8. Again, the truck has to have maximum speed of 88 kilometer per hour. So for V is equal to 88 kilometer per hour in top gear. So these are the given, and we have to find out the four values: engine brake power, engine speed, maximum grade, maximum drawbar pull. So next, these are the given in numerical 2. Total weight W is equal to 62,293.5 Newton. A is equal to 0.018. B is equal to 0.0276. Next, R is equal to 0.8125 meter. Sorry, capital D is equal to diameter is equal to 0.8125 meter. V is equal to 88 kilometer per hour, and it's 88 kilometer per hour. Next, the transmission efficiency is equal to 0.9 in top gear, transmission efficiency 0.8 in second gear, G is equal to 6.2 for top gear, G is equal to 15 is to 15 for second gear, small r is equal to 0.40625. And we have to find out resistance to motion and engine brake power in first condition. Second, engine speed if the driving wheel having effective diameter is 0.8125 meter. Maximum grade the truck can negotiate at above engine speed is second gear, and maximum drawbar pull in second gear. So this is all about given and to find out. Next, so in top gear, we have to find out resistance to motion. So we know the equation. This equation is given in the numerical itself. So R is equal to KW plus Ka V capital A V square. So we know the value of K, we know the value of Ka. So is equal to 0.018. W plus 0.0276 into capital A into V square. So putting all the values is equal to 0.018 into 62,293.5 plus 0.0276 into 5.574 into 88 square. So this V is in kilometer per hour. Then calculating this, we get the value as 1120.3 plus 1191.4, then R becomes 2312.7 Newton. So resistance to motion is 2312.7 Newton. Next, engine brake power. We know the formula for engine brake power is RV divided by 1000 transmission into transmission efficiency. So R we calculated as resistance to motion, that value is 22,312.7 into 88. We know the value of 88 into 1000 divided by 1000 into 0.9 into 3600. So to convert this kilometer per hour into meter per second, we have to multiply by 1000 and divided by 3600. So again, this equation becomes 2312.7 into 88 divided by 1000 into 0.9 into 3.6, that is equal to 62.8 watt. So this is our resistance to motion. R is 112.7 Newton. Engine brake power is equal to 62.8 watt. These all are in top gear. So engine speed and engine brake power is 62.8 watt. Next, in top gear, we have to calculate engine speed. So we know the formula. V is equal to 2 pi capital N into R upon capital G. This is in meter per minute. So capital N is equal to V into G divided by 2 pi R. This is in RPM. So we know the value of V, 88 into 1000 divided by 60 into 6.2 divided by 2 pi into 0.40625. So 1000 into 60 for to convert kilometer per hour into meter per minute. So this value becomes 3564 RPM. So N is 3564. Engine speed is 3564 RPM, revolutions per minute. Next, in second gear, we know the ratio Vs upon Vt is equal to Gt upon Gs. So the speed in second gear divided by speed in top gear, that is equal to gear ratio in top gear divided by gear ratio in second gear. So engine speed is inversely proportional to gear ratio. So we calculate the V is equal to 6.2. We know the value of gear ratio in top, 6.2. We know the value of gear ratio in second gear, 15, into speed in top gear. We know the value as 88. So that is equal to 36.4 kilometer per hour. So we will convert this into meter per second. So we multiply it by 1000 and divided by 3600. So it becomes 10.11 meter per second. So in second gear, to find out resistance to motion, we consider equation as R is equal to Kw plus Ka capital A V square. This is already given in the numerical. So putting all the values, we find out R is equal to 1325.1 Newton. So we put the value of W, we put the value of A, we put the value of V in kilometer per hour, that is 36.4 kilometer per hour. So that R becomes 1325.1 Newton. Assuming that the vehicle can climb the maximum grade of 1 in X, then equation becomes R is equal to resistance to motion plus weight upon X, that is in Newton. So this is R is equal to 1325.1 plus 62,293.5 divided by X. So F is equal to engine, so tractive effort is equal to BP into transmission efficiency into 1000 divided by V. So we calculate this by putting all the values is equal to 62.8 into 0.8 transmission efficiency in second gear into 1000 into 3.6 divided by 36.4, because the V, we know the value of V as a 36.4 divided by 3.6. While putting in denominator, the 3.6 goes in numerator and 36.4 remains is in denominator. So the equation becomes F is equal to 4968.8 Newton. So putting the value in this, R is equal to 1325.1 plus 62,293.5 0.5 divided by x, so that becomes 1325.1 plus 62293.5 divided by x is equal to 4968.8. So calculating value for x, it becomes 62,293.5 divided by 3,643.7. So x is equal to 17.1. Hence, the maximum grade is 1 in 17.1. For this is for value for in second gear. This is value for value for the x, and maximum grade in second gear is 17.1. So next, in second gear, we have to calculate the maximum draw bar pull on level. So the formula is maximum draw bar pull in on level is equal to tractive effort available minus tractive effort for resistance on level. So we know the value of tractive effort, we know the value of tractive effort for resistance on level. So putting these values is equal to 4968.8 minus of 1325.1. So the maximum draw bar pull on level becomes 3643.7 Newton. So this is about the values, this is about the vehicle performance in second gear as well as in top gear. First we find out, first two values we find out for top gear, second two values we have to calculate in second gear. So this is all about a summary of numerical 2. So first we read the numerical very clearly, and then we have to find out what are the givens they have given, then what is to find out in that numerical. So we know the value of total weight, we know the value of A, we know the value of B, we know the value of capital V, that is in kilometer per hour, in vehicle speed, capital A frontal area in meter square, transmission efficiency in top gear, transmission efficiency in second gear, capital G 6.1. I forgot to write capital G for in second gear, that is 15. Small r is equal to 0.04065. How it is calculated? So d by 2. So diameter divided by 2 is equal to radius. Then these are the four values we have to calculate. What is to find out? The resistance to motion and engine brake power. Then second, engine speed, if the driving wheel having effective diameter is 0.8125 meter. Third one, maximum grade, the truck can negotiate at engine above engine speed in second gear. And fourth one is maximum draw bar pull in second gear. So in top gear we calculate value of R, we calculate the value of engine brake power, and then in top gear we find out the value of capital N. So again, next in third and fourth calculations in second gear, we have find out the value of V in second gear. Then we assume that the vehicle can climb the maximum grade of 1 in X. Then we calculate capital R, we calculate the capital F. So X is equal to 17.1. This is the maximum grade in 1 in 17.1, and then finally we find out maximum draw bar pull on level, and that value becomes 3643.7 Newton. So this is all about the parameters considered in the vehicle performance. So mostly in the vehicle performance we have to calculate resistance to motion, engine brake power, vehicle speed, engine speed, what are the maximum grade, what is the maximum draw bar pull. And for V in resistance to motion we have to put that V in kilometer per hour. In the engine brake power, the V must be in meter per second. These two are the main important points we must remember while solving the problems on vehicle performance. So this is all about the numericals on vehicle performance. I think you all of you have understood the concept very clearly regarding the parameters considered in the vehicle performance. Thank you very much. Thanks a lot.